In this video, I'll be showing you how to add and subtract rational expression. First, I wanted to compare the regular fraction with rational expression. On the left side, I have the rational expressions. On the right side, I have regular fractions. Now, the difference between them is just because we have variables at the denominator. So we have variable at the denominator for rational expressions, but we have regular numbers at the denominator for regular fractions. So if you really know how to add fractions or subtract fractions, then I can put to you that you already know how to add and subtract rational expressions. It's the same principle, the same idea. All right, so I'll be going side by side. I'll be jumping between left and right and be showing you the similarity in the process. Okay, I'll start from the regular fractions. So let's say I want to add these two fractions. The first thing I would do is to find the LCD. So I want to find the LCD of the expression, okay, of the denominator. So it's called the common denominator. Common denominator. So I'm looking for common denominator. Okay. To find that, I need to look for the biggest number or the smallest number that both of these expressions can divide evenly into, okay? So now I know from elementary mathematics that 3 and 5, the LCD will be 15. So I'll put the 15 over here. I'll put the 15 over here. So now my job is to find something with which I will multiply 3 by, this number 3 by, to get me 15. So well, I know that I need to multiply by 5. So I'll multiply by 5. But remember, this is a fraction, so we don't want to alter the value. We just want to change to equivalent form. So we need to multiply the numerator also by 5. So effectively, we're just multiplying by 1, okay? So we do the same thing here. I want to change the 5 to 15. So I need to multiply by 3, and then now I can have 15 now, okay? The denominator is now common as 15, okay? Now, the numerator now for this will be 5 times 2. That will be 10, all right? And then this numerator is 3 times 3, and that will be 9, okay? We're almost done, so we just need to add 10 plus 9 is 19 and keep one denominator, okay? All right, so bear this in mind. We're going to do exact same thing over here. So we are going to look for common denominator. We're going to do common denominator just like we did over there. All right, so now this is algebraic expression, so we just need to multiply them. Right, we just need to multiply them together. So it will be x and x minus 8, x and x minus 8. That's a common denominator, just like we had 15 over here. Is the same thing, we just multiplied, okay? Now the next thing is we're trying to change the denominator of the left side to look like x and x minus 8. So if you inspect this, and this, the way to change this x to become x times x minus 8 is to multiply by x minus 8. It already has the x. See, the x is already there. I have an x. So what is missing is the x minus 8. That's what we're going to multiply the numerator and the denominator by, okay? So let me remove the annotation a little bit. And so go back to that. Oops, just trying to remove the annotation. All right, go back over here. This is x minus 8. Okay, so I'm going to put x minus 8 to both numerator and denominator. X minus 8. And then x minus 8. Just like we put 5 and 5 is the same. Now we have the same denominator. Now we have exact same denominator. This denominator is exactly the same as that. Now you can by now guess what's going to happen to the one on the right, where we have x and x minus 8. So x is missing. We just multiply by x. So now what is left for us to do is to do what we did over here. We did 5 times 2 to get 10. we're going to do 7 times x minus 8. So if I do that scratch work somewhere over here, like 7 times x minus 8, I will get 7x minus 56. That is what I'm going to copy to this numerator. 7x minus 56. 7x minus 56. The same way, I want to multiply these together. So I will do x times 3x plus 7. And then you will get 3x squared plus 7x. So it will be 3x squared plus 7x. We're almost done. See, what we did next was we added this 10 and 9 together and keep only one of this denominator. We kept only one. And then we added these two together to get 19, okay? We're going to do exact same thing over here. We're going to keep one of the denominator as a common denominator, x minus 8. And then we're going to add this numerator together. So let's start with the highest exponent. So we have 3x squared. Nothing is adding to the 3x squared, so we copy it down. And then we go to the x terms. That is a 7x, that is a 7x. That will be 14x. And there's a minus 56. There's nothing that adds to it, so it's minus 56. So there you have it. That is the sum. It looks messy, but it's exactly the same thing that you do with numbers, that you do with rational expression. Okay, so we spent a long time trying to explain this. The next example will be a little bit faster than this, okay? Here is the next example. All right, now, sometimes you might need to factor the denominator before you can continue to do the work. All right, so what we have right here is 5 minus x and x minus 5. At first glance, you may think they are the same, but they are not really the same. They are different. So I want to factor that x minus 5. I want to factor it. So it will look like this. So 5 minus x is really negative x minus 5, plus 5. Yeah, if you think about it, that's a negative x, and that's 5. So I can take out a negative 1, and it becomes x minus 5. X plus 5, rather. If you take out a negative, you need a minus 5. So it will be negative x minus 5, okay? So anytime you see an expression like that, it's a way to rewrite it is to pull out a negative. All right. For another example, let's say you have 3 minus x. Well, what to do is to write this as negative x plus 3, which you can pull out a negative and it becomes negative x minus 3. So 3 minus x is the same thing as negative x minus 3. So 5 minus x is the same thing as negative x minus 5. So I'm going to rewrite the left expression to look like this: 5 over negative x minus 5, and then plus 3 over x minus 5. Okay, so the denominator is almost the same now, the way we have it, except the left side has a negative. So what we can just do basically is to look for a common denominator of negative x minus 5. So like this. Common denominator is negative x minus 5 and plus negative x minus 5. So we can have both the negative and the x minus 5 represented, okay? So now the left side is already, this, we already have the same denominator there. We don't need to do anything. But we need to do something to the other side to get them the same. So what we need to do is to multiply the numerator and denominator by negative. So times a negative and times a negative. All right. So now we're almost ready to finish it off just like we have been doing. So this is what we will do now. We got the same denominator. So what we do is to multiply the numerator. Add the numerator together. So we're going to have 5. We're going to keep one denominator. Sorry, my pen. Okay, which is negative x minus 5. And then what we will do is add the numerator together. So it will be 5 When we do plus minus, that is minus 3 really, basically. So the next step is to do 2 over negative x minus 5. Now, in reality, we do not keep negative there at the denominator. We take it to the numerator. So it's going to be negative 2x minus 5. All right. Some people might multiply both the numerator by the denominator by a negative number. But basically, that is sufficient. And that is the answer, the final answer to it. All right. Here is the next example. Okay, so like I said before, you need to see if you can factor the denominator before you do anything at all. So let's try to factor this denominator. One of them can be factored like this. This x squared minus 25 is really x minus 5 and x plus 5. And the other one, there's nothing to factor. Okay, now we're ready to look for a common denominator. So look for a common denominator. Okay. All right. So we have x minus 5 and x plus 5. So x plus 5 is already here. We already have x plus 5 here as well. So we just need to use one of them. Whenever you have more than one factors, the same factor on both sides, rather, on both denominator, you need to pick only one of those. All right. You're just going to pick one of those. All right. We're going to pick x plus 5, which occurs there one time. Actually, let's just pick the x minus 5 first. And then the x plus 5. All right. So we're going to do the same thing. We're going to mash it over here. X minus 5 and x plus 5. So that is the LCD. Basically, just try to match what is the largest factor possible on the other side that has a limited number of factors. Okay, so we've matched them like that, and then we're now going to look at how we can even them out. So we already have x minus 5, x plus 5 over there, which is the same thing we have down here. So we don't need to do anything on the left side. So it's just keep the 3 there. However, the right side is missing the x minus 5. So we need to multiply both the numerator and the denominator by x minus 5 so that they will be matching. So, okay, they are matching now. So what we have is this is matching this now. So we need to complete the process by multiplying the numerator now. 5 times x minus 5. 5 times x minus 5. That will be 5x minus 25. So it will be 5x minus 25. Now we're ready to keep one denominator. And then add the numerator together. So we have 5x, combining like terms, then minus 22. And that's basically the answer. We're done. This is the answer to the problem. All right, this is the last example coming up now. This is the last example we're going to do. What we have here is almost similar to what we had before. We need to factor, if possible, factor the denominator. So we're going to factor. This one needs to be factored. Now, x squared plus 3x minus 10 is basically x plus 5 and x minus 2 minus 5x plus 5. That does not need to be factored. And then we look for common denominator, which is going to be x minus 5. You just pick the one with the highest occurrence of factors and then try to match it. So they will be exactly the same. So now we have common denominator, common. But the left side is complete. There's nothing to do. So we just bring down the 7 there. But the right side is not complete. We need to add, we need to multiply by x minus 2. And then x minus 2. And then we'll have, now this is a very important point that's coming up. You see this negative over here applies to this number here, applies to the 5, which together applies to what is inside the parentheses. So I'm going to use -5 to multiply x minus 2. So be aware of that. So -5 times x is negative. It's going to be, yeah, I need to remove this minus ahead of time so you don't get confused with that. So it's going to be like -5x, and then the -5 times -2 becomes +10. All right, +10. Now we can keep one denominator and then add the numerator, combine like terms at the numerator, -5x, and then +17. And then we are done. So basically, to add and subtract rational expression is not really too hard if you follow these steps. 1, you will factor if necessary. 2, you will find LCD. 3, then you will multiply numerator, multiply such that you get same LCD, multiply to obtain a common LCD. Okay, after that you would keep one of the LCD, keep one denominator, and then you add or subtract the numerator. Okay, I hope this helps a little bit. Thanks for watching.